In this video, I'll be going over our notes, day 2, properties and proofs. So we're going to be looking at all geometric proofs today rather than our equation proofs as well. So when we look at our geometric proofs, we'll always be given something of information that is called given, and we'll also be given a statement that we need to prove. Typically, you'll also see a diagram, and you're welcome to mark that up as you go through the proof if it helps you understand what you're trying to prove and where things are coming from. So the given information, just as a reminder, is what we always put in the first line of our proof. So in this proof, it's telling us that E is the midpoint of the segment BD, and then we also are given that the segment EC is congruent to the segment ED. So we're actually given two pieces of information, and the reason there is just given because it was provided to us. We don't need to prove it any further than that. So we're ultimately trying to prove that the segment EC is congruent to the segment BE. So we filled in part of this proof for you, and you're going to need to fill in the rest of the empty spaces, whether that's statements or reasons or both. So the next statement that I provided for you was that the segment of BE is congruent to the segment of ED. So that segment is here and here. Those two segments are being said that they are congruent, and if we think back to what our given information said the line above, we were told that E is the midpoint of the segment BD. So the reason that those two segments would be congruent is just because of the definition of midpoint. So remember, a reason can be any postulate or definition that we've seen already. And so that's one we've learned, and we're going to use that. Next up, we have a blank line, but when I want to look down to the final line and see what I'm trying to prove, I'm somehow jumping from the second line, BE is congruent to ED, and eventually saying that EC is congruent to BE. So because I've talked about my BE and ED being related, and I want to somehow relate BE to EC, I need to get some relationship between BE and EC happening. So when I look at what has happened above, I can see that ED is showing up in my first line and my second line. It's congruent to EC and it's congruent to BE. So what I'm going to write is that BE is congruent to the segment EC. And I'm going to make that claim because of substitution. So I'm copying down line 2 and I'm replacing the ED with EC. So I'm just replacing the yellow with blue because I was given that yellow and blue are congruent. So I'm using the substitution property there, but you could also think of this as the transitive property because we were taking that blue is equal to yellow, green is equal to yellow, therefore blue and green must be equal to themselves. You can use either reason there and you would be correct. Finally, I'm making the claim that EC is congruent to BE, so the only thing I've done from the third line to the last is just use symmetric property here because I'm switching the order in which this is showing up. And that's because it told me to prove that. So if I had just stopped at line 3, I wouldn't be done my proof because of what the prove statement told me to show. In my next proof, I'm given that the ray MP bisects the angle LMN. So when I have a ray bisecting an angle, I know that those two angles are congruent. That's part of our definition. So now I'm going to be looking to prove that 2 times the quantity, the measure of angle LMP, will be equal to the measure of just one angle of LMN. So all my lines are given to me here. I need to prove all the reasons of why this works. So we're first told that MP, that ray, bisects the angle. Well, that was given. And then we make the claim that angle LMP, so that's connecting L to M to P and drawing the angle, and PMN, which is right here, are congruent. So we can make that claim because of the definition of an angle bisector. Because we were told that it was bisecting, then we know that we can rely on the definition of what an angle bisector is to make that claim that those angles are congruent. Next up, I see that the angle LMP plus the angle PMN, so our two blue angles we've just drawn here, are congruent to the whole angle LMN. Well, that is by our angle addition postulate that if two angles share a ray, then we can add them together to make the angle that is on the outside of them. So that's just my angle addition postulate. In my next line, I have the same beginning, angle LMP, but then I'm saying plus angle LMP is equal to LMN. So the only thing that changed from the third line to the fourth line is that I'm now saying I'm adding LMP again. Well, LMP was up here. We said that it was congruent to PMN. So from the third line to the fourth line, all I did was substitute my yellow angle and my blue angle in for each other. So I'm using substitution here to make that claim. Then my final line says 2 times the measure of angle LMP is equal to 1 measure of angle LMN. And again, that would just be substitution because I'm just going ahead and replacing. And I can also say that this would be simplifying because I'm adding 2 angles into multiplying them by 2. So if you're adding 2 of the same thing, it's the same as multiplying something by 2. So we could also claim that that's simplifying. So either one of those reasons there would be true. And we're going to move on to our next one. Now I have that BC is equal to DE, and we are trying to prove that AB plus DE is equal to AC. So notice here that we don't have any segment markings above these letters. And so that's talking about the lengths, and that's why we're calling these equal and not congruent here. When you just see the letters by themselves, it's length. Remember, when you see it with the symbol above it, it's talking about the actual segment. So segments are congruent, lengths are equal. So that's why we have equal signs here. So we're going to be saying equal to these numbers. So BC is equal to DE. That's given. I need to plug that into the first line of my proof because it wasn't already there, and I can state that that is my given information. Then from here, I'm going to try to see if I can come up with something else. I notice in my proof line, I'm going to need to have AB plus DE is equal to AC. So I'm going to somehow try to get an equation here where I'm adding pieces together. And when I look at my diagram, the only thing that I can really add together here by a postulate would be AB and BC. And I'm allowed to add AB plus BC and say that it's equal to AC because of the segment addition postulate. So segment addition postulate would be our reason here of why we can make that claim. And then when we want to jump down to our last line where I'm changing something, the only thing that changed was DE and BC are now flipped here. So I'm going to say that this is just by substitution, that I made this substitution in for the problem. I took one term, DE, and I changed it from BC because I knew BC and DE were equal. Since they're equal, I can just plug that into the equation and sub it in that one part to make a true statement. We're going to do 3 more proofs, so as we keep going, I encourage you to pause the video and try them on your own before you listen to the explanation if you haven't already been doing so. Next up, our measure of angle 1 is equal to the measure of angle 2 or angle 3. And again, notice how this does not say congruent. We're talking about equal here because measure means a number. Numbers are equal, angles are congruent. So I'm talking about the measure of angle 1 being equal to the measure of angle 3. So for example, if they were both 30, then 30 is equal to 30. That's why we're allowed to make that claim. Because their measures are equal, we could also say that angle 1 is congruent to angle 3, and we might need to use that definition at some point, but right now we're only talking about being equal. And it looks like even in our proof statement, we're still proving measures of angles being equal. So we're using the equal sign, not the congruent sign this time. So my statement is given when I say that the measure of angle 1 is equal to the measure of angle 3. And then I'm making a claim that the measure of angle 2 plus the measure of angle 1 is equal to the angle or the measure of angle CBD. So that's angle 1 and angle 2, and adding them together is making this angle. Well, I can just say that that is because of the angle addition postulate. Then when I have to fill in this next blank, we want to look down at the line below. I'm seeing somehow that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle EBA. So we're somehow now going to be talking about this angle EBA, but it's actually made up of angle 2 and angle 3. So in order to get somewhere with this proof, I'm going to have to talk about how the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle EBA. And that's going to let me start actually using that angle in my proof a little bit more. So that again was just because of the angle addition postulate. We're just talking about 2 separate angle addition problems there, which is why we need to state it separately in 2 lines of our proof. Now we have the measure of angle 2 plus the measure of angle 1 is equaling the measure of angle EBA. So if I notice from the line I just wrote in green down to my fourth line, the only thing that changed was that the measure of angle 1 was replaced with the measure of angle 3. So that is just going to be because of our substitution property that we are allowed to make that claim. And then finally, we are going to go ahead and try to make our claim that the measure of angle CBD is equal to the measure of angle EBA. Well, why are we allowed to do that? Let's take a look at what we've done so far to get to where we are. We're taking EBA and we're saying that it's equal to CBD. So EBA was here, CBD was set up here, and we can see that on both left sides of their equations, we actually have two statements that are the same. We have measure of angle 2 plus measure of angle 1, measure of angle 2 plus measure of angle 1. Since those two things are equal to two separate things, we can use the transitive property in order to make them equal to each other. So the transitive property is our last reason here. Next up, we have the measure of, just angle 1 and angle 2 are supplementary. And then we are also told that angle 2 is 62 and our measure of angle 1 is 118 is what we're trying to prove. So notice there's not a diagram here. You are always welcome to draw a diagram. We are given the fact that we have two angles, angle 1 and angle 2, and they're supplementary. So when I hear supplementary, I know they're going to be adding up to 180. So I'm going to have some angle, angle 1, and I'm also going to have angle 2. So angle 1 is here, angle 2 is here, and I'm given that the measure of angle 2 is actually 62. So that means this angle is equal to 62 degrees. So I'm trying to prove that this angle would be 118. Now in your head you might be able to just see, well, obviously we can add those together and make 180, but we're going to show all the lines that we would need to show of our proof in order to actually make a logical argument for that. So we're given a lot of information. Angle 1 and angle 2 are supplementary, and we're also told that the measure of angle 2 is equal to 62. So these were both given information, so we can fill them into our proof. Then we can say that the measure of angle 1 plus the measure of angle 2 must equal 180. And why am I allowed to say that? Why would those two angles add up? That's just because I'm using the definition of supplementary angles to claim that they're always going to add up to 180 degrees if they are supplementary. That's part of that definition. So then down below, I'm going to rewrite my formula of the measure of angle 1 plus measure of angle 2 equals 180, but I know what the measure of angle 2 is. I was told that the measure of angle 2 equals 62. So I'm going to substitute that value into my equation and replace it there. So that's just substitution property. Now to get my final line of the measure of angle 1 equals 118, what do I need to do to my equation? Well, to get from line 3 to line 4, I would just have to subtract 62 from both sides, meaning I'm using the subtraction property of equality to make this final claim. All right, so then we have our last proof here, and we've got some perpendicular lines. It's given us that the line AB is perpendicular to the line EF. Line AB and EF are intersecting right here, and we're told that they're perpendicular. So I'm going to draw the right angle marking there because of the lines being perpendicular. I also know the same thing about line CD and line EF. So this symbol here, this kind of upside down T, we haven't seen it yet, but it does mean that these lines will be perpendicular. And when lines are perpendicular, we know that they intersect at right angles. So that's our given information. I'm going to go ahead right away and fill that into the first line of my proof since it wasn't already filled in for me. The first line is always our given statement. All right, so now that we've filled that in and we are claiming that it is because it's given, let's take a look at what's next. It says that angle 1 and angle 2 are right angles. Well, that's just the definition of perpendicular lines, and we were allowed to use it because the given information told us that those lines are perpendicular. Therefore, any angles that they meet at must be right angles. Then I'm going to claim that the measure of angle 1 is equal to 90 and the measure of angle 2 is equal to 90. So because of that, I am going to go ahead and just say that that's because of the definition of right angles. The only thing we said in line 2 is that they are right angles, but in that third line, we're actually giving a value to that and saying that it's because of the definition of right angles that they are equal to 90. So my proof statement is the only thing I have left in my proof, the only thing I have to fill in there. And so how did I make that claim that angle 1 and angle 2, their measures are equal? Well, I would have two reasons. I could either say it's by transitive property or by substitution. So we'll talk about why both of them would work. Over here, substitution, sorry, I spelled that wrong. Over here, we've got the measure of angle 1 is equal to 90. And I also have that the measure of angle 2 is equal to 90. So I have two things that are equal to something else. So because blue and green are both equal to yellow, by transitive property, we can set blue and green equal to each other. Another way to think about it would be that if I just rewrite measure of angle 1 equals 90, but I replace the 90 with the measure of angle 2, then I'm substituting in that green for the yellow because green and yellow were equal. So that's why either of those would work. You could claim either one of them if you were filling this proof in on your own. Thanks for watching.